Well, we've reached the end of another week, and well done for getting to the end of week 3. What we did in this week was really concentrate on consolidating what I'd covered in the first 2 weeks. So understanding how to define functions in Erlang, the idea of direct recursion and tail recursion, and particularly seeing lists as a sort of workhorse data type. And hopefully you got a chance to understand how we could deal with all sorts of programs, collections of objects, strings, and so on. All sorts of data can be handled using lists in Erlang. And that also exercises using recursion, understanding how recursion is the key way that we get repetition. We can iterate through a data structure, or we can iterate through count down through a series of steps. Now, we've called Erlang a functional language, but ironically, a lot of what we've seen so far, we could have done in any programming language. In Pascal, for example, you can define functions. You can apply those functions to data structures and so on. I guess among the distinctive things we've seen is that we don't have destructive assignment, we have single assignment, and also that we use pattern matching very heavily to and as I explained in the video feedback from last week, pattern matching serves a number of purposes: to distinguish between different kinds of elements, to decompose elements into their component parts, and so on. But what we'll do next week is do something that is distinctively functional. What we'll see is that functions are not just things that we define, but they are data themselves. So we'll define functions that have functions as arguments. Now, of course, the great thing about that is that we can parameterize the behavior of something on behavior. So, for example, we can see that there are patterns like transforming every element of a list that we call map. And what we do is we apply a function, which is an argument, to every element of a list. So we can pass functions in as data, and as becoming apparent, nearly every programming language now has a lambda. It allows us to define functions which can be used in APIs, because you get much better APIs when you can parameterize things in the API over particular bits of behavior. And the final piece of that jigsaw is that not only can we pass functions that are defined, are named and defined, but we can create functions as a result of applying other functions. So we have functions as arguments in something like map. We have functions as results. We can define a function that takes two functions and composes them together. For example, we can define a function that takes a function and a number and composes that function with itself that number of times. So we have f and 3, and you apply it to an argument, it gives you f of that argument. But we can just say, given f and 3, we get back the function that does this. So we're going to find out all about that in the final week. And that means that we really do functional programming on steroids, as it were. We can write much more compact programs, we can abstract over behavior, and so on. Right, the other thing I wanted to say was to say well done for everyone who's helped everybody else out. I talked about this last time, and it's really good if what you can do is you get feedback from other people, give some feedback back, and you learn both by receiving feedback but also by giving it. So thanks very much to everyone who's been doing that, and best of luck with the last week of the course. Thanks very much. Goodbye.